Hello everyone and welcome to my channel. So today I want us to look at vectors. So whenever you have a vector, it is important to know or remember that it always has the magnitude. So for example, a force will have the magnitude and the direction, which is the angle with respect to the horizontal. Okay, so now this force or this vector always has some component. Another important thing to take note of is that it will always have some component. So this is just a force that is acting at an angle theta there, but it has some components, two components, the horizontal component and the vertical component. So if we were to draw this force here, which we know that it's acting at an angle, so F, it has components, one in the horizontal axis. So this is a component of F, which is X, Fx, and another one, Fy. So these components always act at 90 degrees with each other. So for us to write expressions of these components with respect to the angle and the force, we should make a right angled triangle. So we have F there, and then the components will be one will be in this direction, which is Fx, and another one will be in that direction, which is Fy, and our angle theta is here. So these components are acting at an angle of 90 degrees, which makes this triangle a right angled triangle. And from our right angled triangle, from our trigonometry, we remember that this right angled triangle will have the opposite, because this is the opposite to the angle. Let me write using a different pen. So this one will be the opposite, this one will be the hypotenuse, and this one will be the adjacent side, like that. And we can use trigonometry, we can use SOHCAHTOA to find expressions for Fy and Fx in terms of the force F and the angle. So from the triangle here, we know that sine theta is equal to the opposite over the hypotenuse. So our opposite here is Fy over our hypotenuse is F, which is that force there. And making Fy the subject of the formula, we are going to have, because this one will be over 1. So if we cross multiply, we are going to have Fy times 1, which is just Fy, is equal to F times sine theta. That's so that this is an expression for the vertical component, which is the y component, or Fy. Okay, and then for the Fx, the horizontal component, we're going to use cosine, because we know that cos is equal to adjacent over hypotenuse there, and this is the adjacent and hypotenuse. So cos theta, let's write it here. So cosine theta is equal to adjacent. So the adjacent is Fx, so Fx over hypotenuse is F. And if we make Fx the subject of the formula there, we're going to have Fx is equal to F cos theta, which is an expression for the horizontal component there. So this is important because it enables us to add the forces whenever they are acting at different angles other than 90 degrees, 270 degrees, 180, or 0 degrees. For example, if you have a body that is being acted on by forces. So this one is at an angle, that direction. We can say this one is at angle theta, and we have the horizontal there, and we have another angle in that direction. We say this one is at angle alpha, and we have a force in that direction and another force in that direction. So let's say this is F, this is P, say this is Q, and then this is maybe W, like that. So it turns out we can only add these forces if we find the components for these two forces that are acting at those angles there. Because here we have a component in that direction, which is a component of P, we can call it Px, and a component in that direction, which is Py. Even here we have a component in that direction, which is Qy, and a component in that direction, which is Qx. So this body can be redrawn like this, the same body, and drawing the forces that are acting. We have a force going up, we are calling it F. We have a force coming down, we are calling it W, and we have a force in this direction, which is Px. We have another force in this direction, which is Qx, and we have another force coming down. So we're going to have a force, we use a different pen. We have a force which is Qy, and a force going up, which is Py. Okay, so from this we can now write equations. In the x-axis we only have two forces that are acting, so the summation of forces in the x-axis, so you can say summation of forces in the x-axis is equal to Qx minus Px, because they are acting in opposite directions. One has to be negative, and the summation of forces in the y-axis is equal to F plus P, since they are going up, plus Py, which are these two, since they are going up, minus Qy minus W. So that is the summation of forces in the y-axis. So if the forces are acting, if the body is in equilibrium, or the forces are acting on a body that is in equilibrium, then the summation of forces in the x-axis will equal 0, and the summation of forces in the y-axis will equal 0, meaning our equations will be P, the first equation, Px, or maybe we start with Q, this one here, so Qx minus Px is equal to 0, which can also be written as Qx, when P goes on the other side there, when it crosses over, since it's negative here, it will be positive, so equals Px. And this other one here, for the y-axis, it will be F plus Py minus Qy minus W. This should equal 0. And we can take these other ones this side to cross the equal sign. We are going to have F plus Py is equal to Qy plus W. So this is why it is important to break down the force into its components. So it's very important for you to know how to express a single force into its component. That is all for this video. Thank you so much for watching.